Hey guys, so we're on to 3.3, implicit differentiation, okay? All the derivatives that we've done at this point have been explicit, okay? More likely because it's y equals in terms of x. In this lesson, we're going to be working with what's called implicit, which means there's a relationship between x and y that's applied. We have no idea really what's going on there, but it's implied there's a relationship one or the other. So like how we have this x squared plus y squared equals 1, xy plus y squared, okay, so on and so on. These are all examples of implicit. It is possible to differentiate implicit using implicit differentiation. So what we have to do is differentiate both sides with respect to x. What does that mean? Well, that means for every time we take a derivative of y, we have to add on or like hook on a y prime. Just like when we take the derivative of x, we don't actually put down there x prime, right? Because it's in respect to x, okay? So we're going to, every time we see a y, take the derivative, technically we do that anyways, right? And we put the y prime down. For implicit, what we're gonna do is as we do that, then we are going to solve for y prime and ta-da, we got our differential equation. So, number one here, we're just going to do some basic rules, right? So that would be y prime equals 1. Again, the derivative of y is y prime. For number 2, we get y equals 2x. Number 3, don't forget, this is what rule? It is the chain rule. You could FOIL it out and do the power, that's up to you, but this you could do the chain rule. So we get y, oops, I forgot y prime now. Y prime equals 2, keep the inside, and that of course would be to the first, times the derivative of the inside, which is 2. Okay, next chain rule again, y prime, outside first, so 2, same inside, which is f of x, times the derivative of the inside, which is f prime of x. Okay? Now let's see if we can do with 5 here. Be careful. Remember, every time we take the derivative of y, we need a y prime with it, okay? So the derivative of x is 1 equals, now with the y squared, it's a power rule, so we would do 2y to the first, but we have to hook on a y prime, okay? All right, let's continue on this. Do some more examples here. All right, given this, find y prime. So luckily, we have each term separately. Every time I see a y, I'm going to hook on that y prime, okay? So 2x squared, the derivative of x squared is 2x. The derivative of negative 2y cubed would be negative 6y squared y prime. Remember that hook. The derivative of 3x is 3, and the derivative of 6 is 0. Now I'm going to solve for y prime. So let's get everything over without y. We're left with negative 6y squared y prime equals negative 2x minus 3. Now to get y prime by itself, we divide both sides by the negative 6y squared. And we are done. Okay? I'm going to change, I think my hands are a little sweaty today, so the pencil's not working. So hopefully the pen will work. All right, let's do the other one. All right, that's just finding y prime. Let's see what other questions we have here. Find the slope of the tangent line to the graph, blah, 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 at 3, 2. So we know the slope of the tangent line is doing the derivative and then plugging in. Okay, why is it that we need x and y this time? Well, you'll see with implicit differentiation how this works, okay? All right, so derivative of x squared is 2x. Derivative of 4xy squared is 8. Y to the first, hook on that y prime, equals 0. Then we're going to solve for y prime, because y prime is where our slope comes from, right? So 8y, y prime, equals negative 2x. Divide by 8y, we get y prime, equals, now do we have to simplify? No, so I'm not going to worry about simplifying right now. 8y. Okay, now that's just solving for y prime, but the question was find the slope at 3, 2. So what we're going to do is actually find y prime of 3, which also means that we have to plug in that 2 for the y. So we get negative 2 times 3 all over 8 times 2. And we end up with 3 over 8. And it should be negative. Okay, now that's the slope of the tangent line, and that's all we needed to do. Okay, sorry, my notes are saying the normal line. Just don't forget, if it says the normal line, guys, remember that's the perpendicular, so opposite reciprocal. All right, let's continue. Given y cubed, blah, 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 find dy over dx, evaluate the point at 1, 2. All right, one thing I wanted to tell you, this is where many of you will make your mistakes, so keep this in mind. Right here we have the power, but right here we have the product. Here we have the power. That product is where you're going to make your mistake, okay? So this is what I'm going to do. I'm actually going to leave a space for the product. I'll just do the power first, just so you can see. So we have 3x squared minus, and then we're going to have some sort of product rule in there, plus 3y squared y prime equals 5. Everybody see that? Now, dy over dx technically is y prime. Let's keep it in y prime for now, but in our answer, we need to make sure that we change that. Okay, product. I'm going to do some side work here. So we have 2xy. 2x I'm going to take as my first function, y as my second. Okay, so remember product is the first function times the derivative of the second. Well, the derivative of y is y prime, plus the second function times the derivative of the first. The first is 2x, well, the derivative is 2. So see my product? This is where you guys will mess up. Please slow it down. Now, next, we have 2 y primes. We have an issue, right? So what we're going to do right now is I'm going to distribute this out. Okay, I get 3x squared minus 2xy prime minus 2y. Don't forget that distributing there. Plus 3y squared y prime equals 5. Anything without a y prime right now, I'm going to put on my right side. So I have negative 2x y prime plus 3y squared y prime equals 5 minus 3x squared plus 2y. Okay, now We have two y primes on the side, but what can we do with it? We can factor it out and divide. So because I'm running out of space, guys, I'm going to do all of that at once. So I end up getting y prime equals 5 minus 3x squared plus 2y all over negative 2x plus 3y squared. Okay, so I found the derivative. I actually can write this in as dy dx. Okay, and now I'm taking the prime of that term. So what I'm actually going to do, guys, is make some space for myself. So dy dx, because that's the prime of the point 1, 2, equals, because now all I have to do is plug in my 1 for my x's and 2 for my y's, and when I do that, I get 3/5. Okay? Sorry, that was a lot of work and a little bit of space. All right, 2 more examples, and then we are done. Okay, given the equation, find y double prime. This is going to be tricky. I'm going to make sure that I'm using a pen that won't stop me. Okay, double prime. So what does that mean in our case? Well, let's do implicit first. So we get 2x plus 2y, hook on that y prime, equals 0. Now, the biggest thing is when we are finding the second or third derivative, whatever it is, you need to isolate the first derivative. So just like the steps we were taking before, after we took the implicit differentiation, now we're going to solve for y prime. Okay, so I end up getting y prime equals 2x over 2y. Now, because I'm going to take the second derivative, I actually do want to simplify that more so it doesn't get in my way. Okay, well, the great thing is once we isolate y prime, we can now take the second derivative. So this is y double prime. This is the quotient rule. Ready? Every time you take the derivative of y, we're hooking on that y prime. So low d high minus high d low, there's my y prime, all over low squared. Now, it's very, very tempting to keep it in this form. But if you look, we need it in terms of y. We have a y prime. We have an issue here. So what we're going to do is actually, we know what y prime is. So we're going to substitute that back in. Okay, so we get, did I do something wrong, guys? Oh, guys, I did. This should be minus. That's okay, because this would be a -1 here. And then this would be negative, negative. There we go. Got it. Okay, y times -1 is negative y. This would be plus x. Now, instead of y prime, I'm going to put the negative x over y in. All over y squared. Okay. Could we evaluate that more and simplify it? Yes, but I'm going to keep it like that for now because it doesn't tell me to simplify more. But we could, usually you don't see a fraction within a fraction, okay? You would multiply that out, common denominator, all that good stuff. But let's keep that as is because there's nothing else we need to know. Oh, yeah, we do. Sorry, we have more. Because it doesn't say in terms of x and y, and I have x's in here. Do you guys see that? So what I have to do is I can know that x Oh, that's why. Watch. I got an idea. Sorry. Was wondering why they went further. So I am going to do minus x squared over y squared. We can find x squared in terms of y up here, because x squared would equal 3 minus y squared. You guys see that? Okay, so now I can replace that in there and say negative y minus, and this would be 3 minus y squared all over y, and all of this over y squared. So be careful what the directions say. If it said in terms of x and y, we could have stopped right here. If it said in terms of y prime, and x, we could have stopped here. But because it says in terms of y, we have to stop here because we have x's up there. Okay. All right, given cotangent y equals y minus x, find dy dx. Okay, let's keep in mind your derivative. So this is cotangent. What's the derivative of cotangent? That would be negative cosecant squared. And remember, we keep the same inside, but we have to multiply by the derivative of the inside. So you have to multiply by y prime. Okay, for every y derivative, we have to add on that y prime. Equals the derivative of x is 1, and the derivative of y is y prime. All right, let's see what we can do here. Let's get the y primes all on one side. So I get y prime minus cosecant squared y prime equals 1. We can factor out that y prime. Be careful here, because when you factor out that y prime, we're left with 1 minus cosecant squared y equals 1. And now we can divide. So y prime, let me just go up here so you can see my work. Y prime equals 1 minus, 1 divide, sorry. 1 divide by 1 minus cosecant squared y. Okay, now I want to show you a trick though, because if you didn't know, this was actually one of the Pythagorean identities. So we can actually simplify that even more to 1 over negative cotangent squared y. And what's the opposite, or what's the reciprocal of cotangent is tangent. So these are all possible answers here. Okay, these three. What we have to recognize is those Pythagorean identities. So we have to write those in our notes and keep in mind that they could come into play, especially when you have a multiple choice and you're like, wait, that doesn't look like my answer. All right, guys, try it out. Don't forget to hook on that y prime.